Good afternoon. And I know we downloaded a lot of information today. Everyone's fried. I'm a bit fried, but this one's not going to be too low level. And hopefully this will be nice and accessible for everyone. So my name's Alex Magnay. Last seen acting as CTO at a consultancy called Hensu, where we were consulting, deploying, and managing public cloud for our customers, which were asset managers and hedge funds. So it was all about high availability, high security, regulatory compliance, and companies split across London and New York. I've just come off a big multi-region Azure deployment and using Terraform, and I've come to WinOps for the last couple of years, so I thought I'd try and give something back. I'm going to turn off my... let's go quiet. Yeah. So if you want to follow and say great things at Twitter, and if you want to email me for any job opportunities, then I'm contracting again, so that would be great. Along the way, picked up some badges, been doing this a long time. Any MCSEs in the house? Anyone? AWS certified? Yeah. VCPs? Yeah. CCNAs? Cisco guys? Yeah. Scouts? Computer badge? No? It's one of my proudest moments. Right. Okay, so this talk's mostly about infrastructure, and my background is definitely from the ops infrastructure side, and using on-prem networking, and then more recently public cloud. Started using Amazon and CloudFormation, moved on to Terraform, and then more recently using Azure as well. So I'll just try and give examples of how you use both the cloud platforms, but this talk will be mainly about my most recent stuff on Azure. So I'm going to talk about Jeffrey Snover touched on this in his keynote this morning, comparing of doing DIY, building a private cloud or building VMware on-prem versus adopting public cloud infrastructure service, and while you do, try and convince everyone to just leave it behind. Then I'll get on to why Hashicorp Terraform's a good idea to use that. And I'll describe what Terraform is. Then I'll look at how we use Terraform, how it feels to use it, and the sort of workflow behind it. Then I'll do some live demos. And after the demos, I'll work through why it's good for operations, it's good for security, and it's good for development teams, and how it fits into the DevOps way of working. I'll cover a bit of Microsoft and HashiCorp news, the latest and greatest news about Terraform, and then some tips on the field. So just bits and bobs I've picked up. Try and save you guys from hitting the same gotchas I did. A bit of a warning, I've got a fetish for excruciating PowerPoint transitions. So anyone nervous disposition or easily seasick, look away now. Oh, yeah. So this is from an Amazon Summit 2014, a while ago now. And the catchphrase is, friends don't let friends build data centers. So building a computer room or data center, it's kind of interesting the first couple of times, but keeping it running is a burden, and patching HP ProLiant BIOS versions gets boring quickly. And it's a huge distraction from working on the stuff the business or the customer actually cares about. Is that second Moore's law about the working on stuff that actually adds value versus you just think it's a good idea to do, but no one really cares about it. If you can move your data centers onto public cloud, spin up VPCs on Amazon or VNets on Azure, and just get rid of the commodity stuff, then you can focus on more important stuff. And you know, we're not going to be out of a job. There's tons of other stuff to be getting on with. And the more stuff that's going to make money for your customers, for your company, or keep your customers happy. And yeah, it's even like a t-shirt now. So, I mean, Azure, the planet scale stuff, it's, if you can try and do this yourself, like if you want to put infrastructure near where your offices are or where your customers are, this is the absolutely only way of doing it. And wherever you're based, you can be pretty confident that you've got Azure IaaS with low latency near to yourselves. So zoom in on the UK, we get Ireland, London, Cardiff, Frankfurt in the UK. We've got the Netherlands. 2 more coming in Paris and Marseille by the end of the year, because pourquoi pas? And Sweden is coming along in 2018. So yeah, put your infrastructure close to your users, your desktops, and close to your customers. And Terraform is tremendous for configuring the software-defined networking, the virtual networks, subnets, routing tables, and then they're ready for you to then drop VMs onto, again, using Terraform. And then there's a Microsoft Backbone WAN. So because I've been working with sites in New York and London, and working with express routes, I've just come to appreciate the tremendous speed and bandwidth that you get by just putting your stuff into Amazon. Just putting a web proxy server on Amazon, it's got tremendous internet bandwidth. And building an international WAN to join your offices together is very expensive. Buying capacity on transatlantic links. But if you can put your stuff on Azure, piggyback on Microsoft's WAN, and then ditch your own transatlantic links, you can save yourself a ton of money and help that build your argument on why you're going to save money putting your stuff on Azure instead of paying Colt and Verizon and whoever for your transatlantic links. It's not 100% straightforward, and you're going to need to get in on BGP and build transit VPNs over the top, but it's definitely doable. And then if you blend in other cloud providers, Amazon and Azure as well, you get even more sites to put your infrastructure. And yes, definitely adding more providers, you're going to add more complexity, there's more stuff to learn. But Terraform will work and give you sort of a common interface to dealing with IaaS on different clouds. And if you have a regulatory requirement, say you can't depend on a single vendor, you want to put your primary on Amazon, your DR on Azure, or vice versa, then picking a tool that is kind of cloud agnostic is not going to do you any harm. Also, not too bad if you're a consultant and you jump between different platforms. If you learn one tool to manage them all, that's helpful as well. So, the worst news that no op guy wants to hear, because the worst has happened. The product is wildly successful, and you need to expand. And this is bad news, because you sized your VMware cluster perfectly, and now you need a bigger cluster, more storage. The cage in Equinix is now not big enough to fit everything. All this grief goes away when you start using public cloud, because you can scale up to bigger VMs, scale out to more VMs, more sites, go global. So You got this. You can go Singapore, New York, Hong Kong, Tokyo, California, no problem at all. I'm going there, yeah. So Brexit. So you built your lovely data centers in the UK, and then they say, oh, yeah, we need a corp office in Paris really quick. I need domain controllers, file servers, VDI. I need a trading chain in Frankfurt. Again, if you've got Amazon, Azure, public cloud, everything in Terraform, it becomes a copy and paste exercise to repeat what you've done in one region and apply it to others. So Frankfurt, not a problem. Paris, not a problem. So just dragging things back to the point, managing Azure. So let's get on to Terraform. So may I finally present Terraform, and I'll go into what the hell is it. So Terraform, it looks kind of like this. Ops guys are like, this looks like programming, don't like programming, but don't panic. It's actually quite easy. You've got this, definitely. It's all right. I'll come back to going into the nitty-gritty of what's going on here. So I'll get rid of that. So what is Terraform? It's a way to manage Azure. It's like the previous talk when they're talking about ARM templates. It's a domain-specific language, which is dev speak for. It's there to do one thing, is deploy infrastructure and also can do some PaaS. It's not like PowerShell, which you can do anything in PowerShell. It's just got one job and does it well. Again, it's declarative, so you don't have to worry about how to get everything up and running and wired together and the order in which to do things. You describe, I want a data center that looks like this, with this CIDR block, these subnets, these VMs of this size, and in the background, it will sort it all out for you. It's easy to read and write. I think it's easy to read and write. Previously, I used CloudFormation, and it made me want to poke my eyes out. Terraform is definitely easier. It's not JSON, so you can comment liberally. Please comment everything. It's driving the Azure and Amazon APIs. So it's not doing anything that you couldn't do with pointing and clicking in the GUI or firing off PowerShell scripts. It's shielding you from the Amazon API. It even runs on Linux. So it's written in Go, which seems to compile on anything. So this is important because you're going to have developers running on multiple platforms. You also want to maybe push off stuff so that it runs on Jenkins. So it's super useful that it's portable across different OSs. It's open source, but it's not dead abandonware. It's got a super active community. It's being updated all the time, and it's free. Seriously, it's free. It doesn't cost anything. There's no way to do business. How does this work? So Terraform is not. It's not OS config management. So it's not Puppet. It's not Chef. It's not going to replace those guys. It's not DSC. It's there to get the virtual networks up, drop VMs on, and then you hand over to tools like Chef and Puppet to then turn the generic VMs into different server roles. And it's not an abstraction layer for any cloud. So you can't code up how your virtual data center full of VMs looks like and then throw it at any environment, because to do that, it would have to sort of go down to the lowest common denominator, and useful, juicy stuff that's only works on Amazon and stuff that only works on Azure wouldn't be available. So it's a common, it feels the same, it acts the same, it works the same, but you've still got to be considerate of things that are specific to different cloud providers. So resource groups doesn't exist at all on Amazon. Very noisy slide. It's a plugin architecture of providers. So one Terraform.exe can talk to all sorts of back-end systems, not just IaaS public cloud stuff. So I'm just going to highlight a couple. So it's got your Amazon, it's got your Microsoft Azure, it's got your Google, but it's also got things like VMware vSphere. So you could potentially use the same processes to push stuff out to vSphere as you do to public cloud. It's also got other things in there like Bitbucket and GitHub. So you can use it to manage your repositories. Talks to DNS over here. So after you spun something up on Amazon or Azure, you could repoint your DNS config. So it's got all sorts of plugins for different stuff. Pretty much anything that's got REST interface with create, read, update, delete, it's straightforward to write plugins. On Azure, Terraform can manage these Azure resources. As an infrastructure guy, I've been focused on resource groups, virtual networks, virtual machines. You can also drop into ARM templates. Rick just gave a really cool session. It also plugs into the PaaS services, but I haven't used those so far in my cloud journeys. So here's back to that template example from the Terraform website, and I'm just going to try and. It's not that difficult to read. So we're creating a resource group, which is like on VMware, it's just like a folder or an Active Directory, an OU. It doesn't actually do anything. It's just a useful container for dropping stuff in, but you can permission who has permission to change stuff on resource groups. Which on Amazon, permissioning is difficult. And you end up splitting everything off into loads of accounts, and virtual networking gets complicated. Resource groups, I'm so happy with those. Then we're dropping in a virtual network, which is the equivalent on Amazon as a VPC. And it's this format. It's the type of resource I'm creating, and then what it's going to be called in Azure, and then its properties, name, address space. Location is your region. West US is sunny California. And then another property is the resource group name that this VNet is going to get dropped into. And already this example's showing what Terraform call interpolation, or variable lookups. So instead of repeating a resource group called production and repeating ourselves here, we're referencing it's all in these triplets: type of resource, name of resource, property of the resource. So the resource, it's a resource group. It's called production, and its name is also production. Let's do that. And this makes the code much more readable. As you make changes to it, your changes will flow through if you're cross-referencing everywhere rather than repeating the same or hard-coding the same variables or values everywhere. And then, bang, got right here, hard-coded value, which is a bad idea. You can turn that one into a variable as well. So the workflow, that's trying to cover what Terraform is doing, being a DSC for spinning up infrastructure. how we use it is more like this. So bust out your favorite text editor, but you want to find a text editor that has support for this Hashicorp language, because that'll help you with the IntelliSense, linting, autocomplete. I'm using IntelliJ because when I started with this, that's the one that had the Hashicorp support. VS Code now has Hashicorp language support as well, so you can crack on with that. And if your editor also supports Git, that's going to help you as well. You then run Terraform in plan mode, and that's going to read all the Terraform code it finds in the current directory, and it compares your code to your Azure subscription and works out what's different. So is my code, my desired state, anything like what my subscription looks out, and it builds up an execution plan describing what it's going to do. So it's kind of like PowerShell in what-if mode. If I ran this, bosh, 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 this is all the things that are going to change. It'll also tell you if your code has got errors in it and will just blow up and fail fast without actually touching anything. In the execution plan as well, in the report, it will give you, it's very easy to read, so it'll have green entries for things it's going to add. It'll have yellow entries with a little tilde for things that are going to change, and it'll have red entries for things that it's going to throw away. So if you've got 10 VMs, but your config now says you should have 8, it'll ditch 2 for you. So this execution plan, that can just be taken and becomes your change management and get your approvals and signed off. Then you run Terraform in deploy mode, and it executes the plan, drives the Amazon API, makes changes, and virtual machines, network security groups, SQL databases, VNets, Penguins, fall out. But there's more. This transition's awesome. Oh. Right, PowerPoint acrobatics. So this is it fits into the lovely agile cycles. So we have edit code, do a plan, deploy, but then things change. The VM needs to be bigger. We need more of them. We need less of them. So you edit the code again, check it in, pull requests, approvals, and then redeploy. And you just keep going, iterating through the cycle and adjusting things as you go in small increments. So it doesn't have to be a big bang. Describe the universe, chuck it into Amazon CloudFormation, light the blue, touch paper, and hope for the best. You can start small. Just describe the VNet, fine. Execute, and then add subnets, execute. Add security groups, execute. It's very easy. And when you're done, there's another mode, Terraform Destroy. And you're like, why would I want to destroy this stuff? I've spent so much time building it. But if you're describing a developer's lab or test environment, then after an experiment, rather than undoing all the crud that he put on his VMs and cleaning up and wasting loads of time, they can just ditch their environment, do a destroy. Terraform does a great job of cleaning up every little bit of crud from that it's deployed, because it's tracking everything. So compared to doing things manually in the portal, you delete a VM, but it's left a storage group, a storage account, and a NIC over there, and a disk over there. Terraform will tear things down, and that is going to save you money, because that stops the billing clock. So you get very easy tear up and tear down of environments. So if Terraform had a GUI, which it doesn't, it would be plan, apply, destroy, right? I think I've laboured the point enough now, so moving on. Right. Are we feeling lucky? Can we get out of this? Yeah. So here's me in IntelliJ. The first thing I'm going to do before I get started is, because I've been working in finance and security is so important, coming into this public cloud tooling where you have to get API keys to talk to public cloud services. These API keys, they look and they smell like IDs and passwords, and they're all over the place in plain text, and they make me nervous. So I always look to generate short-lived temporary credentials. So this one is talking to Amazon Azure AD. I'm making a per user app registration. I'm going to check out an API access key, and it's going to be short-lived. So they're like, that fool has put his key on the screen. I don't care, because it's going to expire in an hour. And if I run it again, it's going to ditch that key and give me a new one. So this is also, it's not a system-wide environment variable. It's not a user-wide environment variable that anyone on the box would see, or anything I click on and run will also see. This is a process-level environment variable, so only this PowerShell session and any sub-processes like Terraform can see the environment variable. So it's, I like doing this to get myself temporary creds that I'm not too worried about, instead of storing them in my code. So now I've got some creds, I can talk to Amazon, Azure. Yeah, step one. Plan. So I'm going to run Terraform in plan mode, and it's looking in my current directory, finding my code in there, and it will tell me if I ran this, come on, this is what would happen. Blah, blah, blah. Must get a bigger VM. Awesome, right. So it's going to create 10 things, is the result at the end. Green entries are adds, and let's look at, actually let's kick off. I'm happy to add 10 things. What's the worst that can happen? Terraform apply, let's make it do it. And then we'll look at the code and see what it looks like. So it's off creating stuff. So this was the code behind it. I'm starting with a resource group with a name and location, UK South in London. In that resource group, I'm dropping in a virtual network, 10 range /16, and I'm then going to drop into my virtual network 3 subnets. This is the kind of pattern we've been doing when we're deploying sort of hedge fund in a box for our customers to lift and shift them from on-prem onto public cloud, that we end up with a shared services subnet where we put domain controllers, file servers, stuff that everyone needs to be able to get access to Atlassian stack. Then we have a production subnet for the trading chain, and then we have some dev subnet where we let the developers go crazy and experiment with. So there's my 3 subnets. They look, it's this resource type, name, and then properties, and liberally commented so that anyone else looking at this or picking it, well, I'm looking at this in 6 months' time and I can try and work out what the hell I was doing. Then I'm doing a public IP, which is like an elastic IP on Amazon. And this IP I can then pin to any VM. I'm making a security group, which is like firewall rules, not to be confused with Active Directory security groups, totally different thing. These are firewall rules. On Azure, security groups can be applied to an individual NIC, or they can be applied to a whole subnet, which so there's no knuckles that you have on AWS. It's security groups for everything. In this security group, I've got a rule that's going to say RDP in from here. This machine can get to over TCP, and using this port can get to my my VM. Then I've got a NIC. I've got some managed disk and a VM. So I've had to just create all these bits and bobs just to deploy a VM. I'll show you a bit later how you can wrap all this up in a easy to use module, which is kind of like a function. And then the developers will use this and just say, give me a VM, and they won't have to know that you have to have a NIC and a storage account and all that stuff. Let's have a look what it's done. Still creating. This takes 3 minutes or something. So, any questions so far?
Can you execute some script after the VM is created?
Yeah. So the question was, can you do your bootstrap scripts? So on Amazon, it's user data. On Azure, it's VM extensions. So you can definitely put in, this is what runs locally on first boot, and you use that to pull in Puppet agents, Chef agents, register in your config management, and then config management will take over. You can also run scripts locally on the machine you're deploying from, which yeah, so if that starts feeling hacky, but you could, for example, register this new VM in a central config management, and that config management system could reach in and take over. Okay. Infer a script.
In the way that previous demo showed the automation option.
Sorry, I don't understand what you mean.
So let's say I've got a VM set up in Azure, and I want to generate a Terraform script that would re-provision it.
Right. So can you do a manual deploy, look in Resource Explorer, see what has been deployed, and sort of reverse engineer that to become no.
That would be nice.
Well, as we saw in the Resource Explorer, there was also lots of CRUD that you'd have to sort of clean out and you don't care about. You have to start from scratch with Terraform. So it's done an apply, and it's added 10 resources, and in my, I'll come back to that one. In Azure Portal, I've got my VM and it's starting up. Now, what I'm going to do now is, there was a deliberate mistake. Everyone spotted it, of course. So I was talking about RDP here, but I've got port 22. It should be 3389 for remote desktop. So now my code doesn't match what's in real life. So if I do a plan again, it's going to compare my subscription to my code, and it works out there's one thing that's wrong, one thing needs to change, and it's saying I'm going to throw away this security rule with this funny number, and I'm going to replace it with the correct security rule. Where is it going? Yeah, actually it's this way. This rule goes to nothing, and this rule goes from nothing to the right settings. So now I can fix my foolish mistake, plan, apply, and rapidly sort out what I was doing. Also, if I'm using source control, I can revert back to previous version, which means there's a lot less fear in pushing out changes if I know I can always revert back, and it's fantastic for firewall rules around VMs, which as you grow and grow, especially for things like virtual appliances, virtual network appliances, these firewall rules can get pretty hairy and are bad news to maintain manually. I've got another example, which is going to be a bigger one. Terraform. Yes. Right. So this is an example for a larger deployment in multiple regions when we were deploying stuff in London and New York. And it's going to chuck in all sorts of stuff, multiple subnets, and lots of different firewall rules. 40 objects, 40 plates we're keeping spinning. If we look at, Terraform. In this example, I've split up, here we go. You don't have to have one big file. I've split them up into a file for resource groups, a file for security groups, one for variables, where I can describe things like, I can do a map, which is a nice lookup table, so I can give friendly names for IP addresses that would be, if you just looked at it in the code, would be hard to remember what the hell is this range. So if I go to my security groups, I'm referring to I'm doing my lookups on my maps. Now, did I apply that one? Say apply. So I'm going to get onto the scenario of Crazy Dave. So there's always one ops guy in your team that's more about trouble blasting than troubleshooting. He's like, oh, it's not working. I'll make it domain admin. Hey, it's working. It's because you can go into the Amazon portal and start clicking around and changing stuff. It's very hard to know why is it working now. It wasn't working yesterday, but did you change something? I can't remember now. If you've codified everything, then you've got an idea of you've got a record checked into source control of how things should be. So I'm going to go in and dick with stuff. Resource groups. Top-down traders. It's my favorite lab environment. Where's my... So in my resource group, I've got stuff. I've got my firewalls. Oh, did it make that again? Right. Security groups, FortiGates. I like FortiGate firewalls. They were really good for connecting to Azure and doing all the express route stuff. And I'm just going to, having trouble with my firewall, what I'm going to do is I'm going to add an inbound rule and allow SSH from, come on, let's do it. Any destination port. Any. What a bad idea. Okay, Dangerous Dave, Crazy Dave has put in a change, and suddenly the firewall's working magically. But, in all of this, how are you going to find out what that guy did overnight? Of course, Terraform is going to back you up. Plan. So, compared to my codified Terraform infrastructure as code, there's everything's all the same except for one thing now. It's a bit hairy to read, so if you there it is. This security rule here should be not there. All this stuff goes to nothing. So I can find that Crazy Dave did something, and I can undo it. Terraform apply. This is like group policy for infrastructure as a service. I can enforce configuration. This is, it's just going to go same. It's just like a big diffing engine. Bosh. Anticipation. One thing got changed and we're back in business. That's dangerous, Dave. I've done this, I use this one for a security talk. In this corner we have firewalls, encryption, antivirus software, and we got human error in the other side. So we can put in all this clever security stuff and we still need to, we've got the people. So you've got just shield, you can almost use this as a monitoring tool or an enforcement, just running it in plan mode on a Jenkins test script. You can find out quickly if your virtual data center has drifted from where it's supposed to be. Enough of dangerous Dave. My last but one, Terraform plan. Actually, put it up to the top. So Terraform plan, I'm going to show how we can have the ops and devs guys living in harmony with their, we can delegate management of the development environments to the dev guys, give them some Terraform and let them look after it themselves. Instead of ops being a bottleneck and a gateway and the custodians of the data center, we can start handing some of this stuff over. Because they get code. This is not a problem for them. They're happier than in this kind of environment than most ops people. So it says it's going to add 8 things, Terraform apply, and then let's kick that off and look at the code. Step two, this guy. So I'm creating a resource group, which is a folder, a container for ops stuff, where we can put the shared services, the stuff that we want to stay how it is, not get accidentally turned off, not get deleted. We can put that in an ops resource group and permission that off for ops. And then we can make a second resource group for development. And we can then delegate access to that resource group, give them contributor level access just to that resource group. And we can then, is that finished? Hand over some example Terraform code. Yes. So if we give this to ops, I'm using this IntelliJ where we can fold up the code in this resource group, and all the virtual networking and the complexity of linking everything up. I can still do security groups around the entire ops subnet to control what traffic can come in and out. But I can let them manage the security groups, the firewall rules for their application. So as they add new services and change ports, they can update their code and ops don't get in the way. And they can spin up their own VMs. Now, in our first example, spinning up a VM had all these bits of a NIC and a storage group and a disk. We can wrap all that up in modules, which is like a function in PowerShell. And that's just in a subfolder. We can then pass parameters to the module. So we can say this VM is going to be called UK South App 1. It's going to go into the dev resource group. It's going to in the primary Azure region, which is a variable. They can look up the UK South dev subnet from our mapping table, or they can actually, you can thread the output of one Terraform state and give them read access to ops Terraform state file, so they can actually look up useful values they need, like the subnet IDs. They're referencing their own security group that they're managing. They're picking a VM size, and they can then change size up, size down. And then tags, for God's sake, use tags, because this is how we're going to bill them, try and work out where the costs are, find CRUD that, we can say that anything that doesn't have a tag, that hasn't been deployed by Terraform, we can script against that, find all the untagged stuff, and we can destroy it, do the tag bot. So we can say, yeah, this is Crazy Dave's lab, and if Crazy Dave leaves, we can find all his stuff and kill it off. So if I put my developer, if I step into a developer's shoes, a developer would then do Terraform. If I could type, I would be dangerous. Terraform plan. Developer would run Terraform plan on Monday morning, and that's all. That's his environment that he's going to be working on throughout the week or through the sprint. Hits Terraform apply, then goes off and has his stand up. And when he comes back, he's got a fresh environment. Did I actually, am I spinning up the VMs? Yes. I'm spinning up 3 VMs. Terraform automatically parallelizes. So when it compares your code to Azure, builds an execution plan, it's building a graph of all the resources and how they have dependencies between each other, and it will parallelize wherever it can. So in here, it's kicking off the deployment of 3 VMs in parallel. So overall, the deployment will take the time of the longest VM that takes to spin up, which in this case is a Windows 10 client for this lab environment. Right. I'll leave that running because that takes 7 minutes and it's not useful. Yeah. Yes, you can. Limited. It's not great, but you can do conditionals and say if it's a dev environment, have a small VM. If it's production, a bigger one, for example. You can make use of the mapping tables as well. So you can, as you parameterize stuff, you can say if deployment is prod, VM type is X. So there's some, but your mileage might vary depending on how much conditional you need. Or you can manage that elsewhere. You could automatically generate some Terraform as well. You can generate Terraform as JSON files to be consumed and pulled in with this. I think that's not too bad so far. How are we doing? Okay, so Terraform for operations. So we're showing doing infrastructure as code. You get more consistent deployments, less manual errors, very easy to repeat a deployment from one region into another, becomes a copy and paste exercise. Less manual errors and subsequent troubleshooting. And I only showed Azure, but you can drop AWS. Works exactly the same. You don't have resource groups. You don't have VNets. You have VPCs instead. But how it looks, it's very similar. With source control, you can version your code. You can go back to a previous state. You can delegate dev environments to the dev teams. Give them a resource group. Get them started with Terraform, and just let them go. You can bill them for it, but as long as even if they're costing a bit more money, as long as they're being super effective, they're working on the stuff that the customer, the business, actually cares about. This is nice. You can give your execution plan to someone else to apply out of hours. So no more dialing in at the weekend and pointy-clicky and fingers crossed you got the right steps in the right order. You can do the plan and someone else or a scheduler, Jenkins, something like that, can kick it off at the weekend or out of hours. Nice. Terraform for security, guys. So we can kind of enforce configuration. We can compare how things should be to how things actually are. We can alert on that. We can also roll things back. If you're using Git, you've got to use Git with this. If your commit histories and your pull requests, you can see who changed what, and if they're putting sensible comments in their commits and tying them back to Jira tickets, for example, you can see who changed what and why, which is very useful for compliance. Delegate Azure access to a scheduler. So instead of all the ops and dev guys having delegated access to resource groups or the entire subscription, you can give them permission to commit changes into Git. And then you can have scheduler like Jenkins and TeamCity applying the changes and just give credentials to Jenkins and TeamCity. Maybe give everyone read access to Amazon or Azure in the portal. But if you want to make changes, you have to commit them in. It's got to be a pull request, it's got to be approved, and then Jenkins will apply those changes on your behalf. This is very, very nice instead of having lots of people with lots of access. The security concerns, this is a bit of a bugbear of mine. These long-lived API access keys freak me out. If you follow the Terraform, right. Don't do this. And I'm not being paranoid. There was a great talk at the last Amazon user group in June. This guy, Burning Monk, wrote code to rip out the keys which were left in plain text in the Amazon INI files in default locations. Don't do it. Great for devs and ops. Ring fence your ops stuff. Let the developers play using resource groups. And then if it's that easy for developers to manage their environments, and it saves you money by cleaning up. And Microsoft has Hashicorp now. It's all Microsoft is backing Hashicorp. Microsoft people working at Hashicorp. Lots of stuff in the news. It's all over Channel 9. Microsoft have said Terraform has got momentum. This is definitely the way to go. Terraform is going to be around. This is an open source product to definitely use. And it's a safe bet. Even Google are getting on board and backing Hashicorp now. And don't mix manual and Terraform. Pick one or the other. You can't do both. Start simple, build up. Get your naming convention in early, it's hard to change. Tag everything deployed by Terraform, and then you find all the stuff that was manually dropped in and easily find it. Comment everything. Use modules, variabilize. The state file stuff is another business. Do your homework, understand how the state file business works, put it on blob storage. Ops need to learn Git, which blows their minds, but you got to do it. Stay safe, don't use those access keys. Docs, there's examples in GitHub and a Terraform book, and go forth and deploy.